So, hello, everyone, and welcome to our webinar dedicated to the Energy Savings Calculator. So, this webinar will be presented by our National Sales Manager, Mario Mongrain. So, we will start with an introduction and then a brief overview of the standard, the product related to the Energy Savings Calculator. And then we'll be presenting the tool and its features. We will have a live demo, and then at the end we'll have a Q&A session with our expert. So please feel free to ask your question at the end of the presentation and enjoy the session.
Thank you, Elia. So my name is Mario Mongrain, National Sales Manager at Delta Transformer. I've been with the company almost 19 years. Thanks to everyone joining on this Friday afternoon, depending on which time zone everybody is. We chose that 4 p.m. Eastern time window because we have lots of customer in Vancouver, so it's only 1 p.m. for our friends in British Columbia. So anyway, so we'll get started. So again, Mario Mongrain, National Sales Manager. I have on the line with us this afternoon Stéphane Bolduc, our Regional Sales Manager for Central and Western Canada, and also Alia Belkoha, our Digital Marketing Specialist. Alia is doing an amazing job, and it's with her work and effort that we have this new tool online that I'm very, very thrilled to present to every one of you. So, with all that being said, let me share my screen and I will ensure that we are good to go. So, Alia, you see my slide?
Yes, we do.
Okay, perfect. Great. Thank you.
You're
So
welcome.
let's get started. So we'll try not to go above this 30 minutes because it's almost it's almost end of the year and had a long rough week. So I'm looking forward that first sip of wine. So again, so I'm just gonna go back in time a little bit to talk about efficiency and rules and NRCan and CSA because in our marketplace there's lots of confusion about who does what, who's in charge of what in regards with efficiency. There has been lots of changes over the last decade in regards to efficiency. So just so that everybody understand who's the player in regards to efficiency in Canada, what's their role and duties and responsibilities, and then I'll talk a little bit more about transformers and efficiency and how we make them more efficient, and then I'll present you the tool. So that you can have the right background to understand what the tool will provide you as the output and the information out of that tool. And again, if you have any questions, just log them in the chat, and at the end of the webinar, Alia will provide me with all your questions. So we talk about a lot about NRCan and CSA. So let's start with NRCan. So mainly NRCan, it's Natural Resources Canada. So it's the federal government, and their responsibility is to put in place laws and regulation in regards with efficiency for all type of electrical products, including transformers. So that being said, for transformers themselves, their role is to ensure that there's a regulation for, I would say, imports of Canada from transformer being built in other countries, and also to ensure that when there's transformers being built in a province and being sent or shipped to another province, there's also harmonization of those standards. Um, because if I give an example, Delta, the plant is based in Quebec, so when Delta ships within Quebec, the NRCan standard does not apply because we don't ship outside of the province from which we built. So in those cases, we have to rely on the provincial regulation. And for a while, it's been quite, I would say, broken. Uh, Quebec had no regulation for a while. Ontario put in the Green Act around 2019, 2020. So but now everybody's on the same page. I said so mainly Canada, Quebec, and Ontario. They have local regulation. And this is in the two provinces where all of the manufacturer, most of the Canadian manufacturers are located at. So, and again, also in Arcan, make sure that the transformer will meet the efficiency dictated by which standard it's used. And NRCan uses a standard from CSA called CO2.2 as a standard for the calculation and the requirement for efficiencies in transformer. So NRCan, it's our government, so they have lots of resources. So they have a nice website, and in their website there's a transformer section because as manufacturer we have to prove that we comply to the law. So when we have a product that is built to be compliant to the law, we have to provide an Arcan with our data that they publish on their website. So if you have a manufacturer name, a part number, you can go on the NRCan website and you can put in the information and you will have all of the data of that transformer. So all the information that's been provided by the manufacturer to NRCan. That being said, NRCan sometimes it takes them a while to publish the information. And a transformer manufacturer, just to provide you any idea of how it works, when we design a product, so we do a full series of tests, including measuring the losses and the efficiency. We provide the data to NRCan, they approve, and then we can manufacture that transformer based on that design that was provided to NRCan. So, but we don't remeasure the efficiency of that transformer every single time we build it. Um, it's not required by the law and it's not required by CSA. So there's rule and there's regulation, but there's not a lot of enforcement. So sometimes it could be easy to cheat, if I could say, from a manufacturer perspective. But the Delta, we have solid standard, and we're not shy to have any of our transformer, reversed engineering and tested so that we meet all of the standard and we surpasses them. So that's one of the things that I'm telling to everyone. The standards is the bare minimum. You have to be above the standard. If you're below the requirement of the standards or the law, you're illegal. So saying that you meet the standard is just okay. It's like your exam at 60%, but you can exceed the standard, and this is where Delta is aiming is to exceed the standards. So that's for the portion of NRCan, and then we have the standard from CSA, which is CO2.2. So that's the standard, which is mainly the test method and the values of efficiency that we have to meet for transformers. So NRCan dictates the law and uses NRCan. So we use CSA, and we use the CSA standard to conduct the test and to ensure that we meet those levels dictated in that standard. That being said, depending on which type of transformer you have, the efficiency level is not necessarily the same. So just to give you an example, um, some lower transformer kVA so will require a less efficiency than larger transformer. Low voltage transformer 1.2 kV class and less, we have to meet the efficiency level at 35% load. And power transformers, so 2.4 kV class and above, we have to meet the efficiency level at 50% load. So that's the only point in all the efficiency curve that we have to comply. So we are measured and everybody's measured on that same level. So depending on your load level that your product will be exposed to, your efficiency can be quite different. So that's the information that the tool will provide. Also, an important note: it's not all transformers that are included in the CSA 02.2 standard. It's quicker to just talk about the what is excluded. So mainly single phase and three phase. Anything below 15 kVA is excluded from that standard. Any single phase transformer above 833 kVA is excluded. Any transformer above 7.5 MVA is excluded. Any distribution or power transformer exceeding 4,000 amps on the secondary is excluded. Drive isolation 15,000 amps, 1,500 amps, sorry, is excluded. All non-ventilated transformer, so NEMA 4, NEMA 4X, mini power center, epoxy potted transformer, those are excluded. All auto transformer, they're excluded. So for all of these products, we don't have to meet any minimal efficiency. So there can be big variances from manufacturer in regards to the losses and the efficiency of those products. All I would say all the specialty product like rectifier duty transformer, multiples, drive isolation, testing transformer, welding, current transformers, and anything that doesn't have a 60 hertz nominal frequency, they're all excluded. So if you have to deal with those type of transformer and the efficiency is important, heat rejection, ensure that you compare apples to apple and ask your manufacturer about getting the right information. So I was explaining earlier that depending on your kVA and your voltage class, the efficiency level will be different. So that this is how the CSA CO2 standard is built. So they provide us with tables. So depending on your kVA and voltage class and your load level, you have to meet that efficiency level. So we calculate efficiency based on those requirements, and if we comply, we're good. We can build and manufacture those transformers. One thing to remember about transformers, and that's a very important point, you have two types of losses in a transformer. You have no load losses, the losses of the core itself, and you have load losses, the losses of the windings. Load losses core, as soon as you energize a transformer, the core magnetize, you're stuck with those no load losses. They are present even if you have nothing connected to your secondary. So that's one thing you have to look at. And this is one way we can make transformer more efficient is by lowering those no load losses. And then we have load losses, the load in the windings themselves. And those losses are not linear, they're exponential. So the more you load, the more you have losses. So at 50% load, you will generate 25% of your losses because those losses in the winding, the load losses, they increase to the square of the load. So zero point 0.5 times zero point 0.5 equals 0.25 times your full load losses. So the more you load the transformer, the less it is efficient. And when you reach 75, 80, 85%, your losses really increase. So just looking at a drawing and a efficiency level will not you provide what's the consumption of energy of that transformer and what's your cost of energy. So this is where our tool is coming into play. So that being said, I'm going to jump here on our website. So out of our support section of our website, we have our new energy saving calculator. Um, this is made for transformer 600 volt primary, 120 to 08 secondary, from 15 kVA to 300 kVA. So, which is probably 85% of the transformer out there in the marketplace, installed in all buildings. So with just putting in some very simple information, simple data, you will get the information. So I'll run a quick one here. So let's say our transformer is loaded at let's go at 50%. My cost of energy is 15 cents a kilowatt. I'm using my transformer 24 hours a day. Or let's say we're having a break. It's only 20 hours a day. And it's a 365 days a year. I'm looking at a 150 kVA transformer made of copper. And then I just push calculate. And then here all those fields will populate. So the first column here is for transformer being built before 2012. The efficiency standard, every most of the time it's every 6 7 years we have changes and we have to meet more efficiency. So before 2012 there was an efficiency set back in 2006. So we could go back further down the road, but let's just say, before 2012. So the losses in your core, no load losses, your load losses in the winding. So based on your input data, your annual cost of energy, so the energy burnt lost in that transformer is over $2,000. For the same type of transformer being built between 2012 and 2010, you go down to $1,700. So you save about $400 a year. And if you use a current transformer for the efficiency 02-2-18, which is in place since 2019, then you save almost $1,000. And over 30 years, we put the savings over 30 years because the average life expectancy of a transformer is more or less around 30 years. So that provides you an overall saving uh, over that period of time. So as you can see, just one transformer at 150 kVA, loaded at 50%, you can save $28,000 over the life of the transformer. So it's pretty easy to calculate your return on investment by replacing the transformer. Replacing a transformer will not only provide you saving on cost of energy, will also provide you a more reliable transformer, a transformer that will reject less losses in your room. So it's your room, the electrical room will be easier to have temperature control, less heat rejection in the room. So everybody's gaining, and also the energy saved within the transformer. Uh, Over here you have like 5,300 watts of losses, and in this one you have like 3,500 watts of total losses. So this is one transformer. So that energy, instead of being burnt in losses in the transformer, can be used somewhere else in the system of your building. Uh, the other nice thing about the tool is once you have compiled your data, you can export that into a PDF file and it will pop up through your browser. Sorry, my computer is quite slow today. And you can also do the same with Excel. So once you have all of that, you can compile your data and you can create a big Excel spreadsheet with if you have a survey of 10, 12, 15 transformer you want to do within your building. Just for fun, let's do another one. Let's do 70% load. I'm lucky. I'm in Quebec. I only pay 8 cents a kilowatt. I use it 24 hours a day, and I got a 225 kVA made of aluminum. Calculate, boom, same thing. You have your information, you have your losses, you have everything, you have your cost of energy, saving over a year, depending on which period your transformer has been purchased, and your saving over 30 years. So for a 225 kVA aluminum unit, 70% load, which is probably the average load on a transformer, almost $58,000 of saving over the lifespan of the transformer. So that's a lot of money. So again, great tool. Just put in a few information, and it provides you all of the information. Just to give you a look of what the output looks like. So in PDF, mainly is what you have seen on the screen. So it provides you your input and then the output, and in Excel format. It's going to be the same type of file, but in an Excel sheet that you can again populate and create yourself a big spreadsheet with different folders to have all of your data. That being said, out of our calculator, our online calculator, We have used the data from Delta Transformer. So mainly behind this, it's a massive Excel calculator spreadsheet, but all the losses for each type of transformer, from 15 to 300 copper, aluminum, based on those three alteration of CSA, we have used the delta value. So mainly our engineers dig into our archives and they have put all the losses measured on our transformers. So this is not something we have invented. It's something that we can prove by providing test results from transformer being built 15 years ago that these are real losses. So this is information and data that you can trust. It's not something that we have pulled out of a rabbit somewhere. So that being said, that's all for me. Have fun with the tool, play with it. If you have any questions, concerns, need support, you can contact your local Delta representative agency. You can contact Stefan, any anybody at the Delta sales office for support. So I'll open the deck for any questions if there's any.
Hello, everyone. If you have any question, please feel free to ask it.
And if anybody has question that pops out maybe tonight or tomorrow, just send us an email and we'll be more than happy to get back to you. So
Okay. So
no question.
for now, I don't see any question.
It's an easy crowd this afternoon. I guess everybody wants to give me back what 9 minutes of my time. So again, thank you everyone. Thank you for your time. Again, the tool is there. It's live. It's online. We also have a little flyer also on our website that explains a little bit about transformer, about efficiency, provides some more data that shares a little bit of what I've explained this afternoon. So again, um, have fun, play with it, and if you have any question, if you need our support, feel free to reach out. So that being said, I'm gonna wish every one of you a nice weekend. Take
Thank you
care.
so much, everyone.
Bye
Thank
bye.
you. Have a good weekend. Thank you.
Thank you, everyone.
Thank you.